We've already talked about what happens when the price of good one changes or increases, and the answer was that the consumer could no longer afford to stay on the same utility level after the price increase. So what happened there was actually, given this utility level U0 and a budget line here, the budget line actually pivots because of the price change in good one, and now the consumer is forced down a new utility level of U1. Now what we want to look at here is what happens if the price of good 2 changes. Well, it simply pivots on the horizontal axis instead. And what if the price of good 1 and the price of good 2 change at the same time? Then our budget line actually goes down or shifts to the left and changes its slope. So what happens, for example, if the price of good 2 changes, then the intercept here would actually go down, and the intercept on our horizontal axis would also go down. By what proportion, however, we don't know. So let's just set an example here. The budget line could look like this, could look like this, could look like this. It could even be parallel to the original budget line for all we know. But in this case, let's just say that it isn't parallel, like this. So the consumer, again, is still forced to go down to a lower utility level because of the price increase, since he can no longer afford to stay on U0. So now he would be forced down here on U1. Let's just say this actually is tangent to the budget line. So in this video, what we'll be talking about is how would the consumer, or how much does the consumer need to actually stay on the original utility level that he was in? And the answer to that is that he needs a push in his budget or an increase in income. And that is what we call the compensating variation. That is what we call the compensating variation. In short, our CV. And so what we're trying to find with our CV is how much the consumer has to get or has to receive to stay on the same utility level. To find the compensating variation, we have to remember what we're trying to do on our indifference map. What we're trying to do on our indifference map is to move our budget line or shift our budget line to the right so that it would be tangent to the old or original utility level. And so this actually gives us a clue. We're trying to stay on the same utility level. And again, to find the compensating variation, we have to remember what we're trying to do in our indifference map. And what we're trying to do in our indifference map is actually to help the consumer shift his budget line to the right or upwards such that his budget line would now be tangent to the old indifference curve. What this means is we're trying to give some income or some more budget to the consumer so that he would reach his target utility level. And that keyword there is target utility level. This gives us a clue that actually what we have to do here, what we have to use, is the expenditure minimization method rather than utility maximization. And so if we recall, our expenditure function is actually a function of P1, P2, and U. And so what we're trying to do is actually find the difference between the new expenditure, which we will denote as E1, and the old expenditure, which we will denote as E0. And this tells us how much more expenditure or how much the consumer has to spend, how much more the consumer has to spend to stay on the same utility level. And this would be equal to our compensating variation, or how much the consumer has to receive to stay on the same utility level. Now, what is E1 and E0? Yes, they are the new and the old expenditures that the consumer has to make. But how do we calculate this mathematically? How do we find the new expenditure that the consumer has to make? The answer is the function or the expenditure function that we have right here. We simply have to substitute the old prices and the old utility level into E naught. So E naught, let me scroll down a bit. E naught is actually equal to our expenditure function, where the old price of good 1, the old price of good 2, and the old or original utility level have been substituted in. E1 on the other hand, has the new prices substituted into the expenditure function, but the utility level is the old utility level, since we are trying to we're targeting, or we're trying to bring the consumer to that utility level, which is U naught. Let me change something here. This is supposed to be 2 and not 1. I guess you might be wondering what happens when only one of the prices of the goods changes. So let's say that only the price of good 1 changes, but the price of good 2 remains constant. Then our new expenditure, given the prices of good 2 remain constant, would now be E P11, comma, P2 naught, comma, U naught. And if the price of good 1 stays the same and the price of good 2 changes, then this would be E P1 naught, P2 1, comma, U naught. And so now we know how to find the compensating variation, or how much the consumer has to receive to stay on the same utility level. Let me close this bracket here. We also have what we call the equivalent variation. The equivalent variation, which we will denote as EV. And what the equivalent variation is actually the change in income of the consumer, so that his utility level would decrease or increase rather than have the price change in the economy. So let's look at our indifference map here. And we have this original utility level again of U naught, and this original budget line right here, and the optimal consumption of A here, optimal bundle of consumption, so X sub 1, X sub 2. And let's say that the government actually sees the prices of good 1 and good 2 changing. And so let's say that the price of good 1 and good 2 change to this level right here. And so the consumer would now have to lower his consumption and will be forced to move to a lower utility level of U1. Let's call this, that's not a nice graph. Okay, U1. So the optimal consumption of this consumer would be here at point B. So what the equivalent variation is that how would the government, for example, how would the government reduce the income of the consumer so that his utility level could go or move to U1 without changing the prices of the goods? And so what we're trying to do is actually to shift the budget line, shift the original budget line to the left or downwards, so that this original budget line would now be tangent to the new utility level if there were actual price changes. Now, I know this may sound confusing, and it is really confusing at first, but maybe after a few examples we'll understand how the equivalent variation actually works. So again, what the equivalent variation is trying to do, what the EV is trying to do, is to actually decrease the income rather than increase the prices of the goods. So again, given this utility level, let's say given this utility level, and the original budget line here, let's say that the prices of the goods will actually decrease this time. So let's say that after the price change, the new budget line of the consumer looks something like this. And the consumer would now be able to consume or reach a new utility level. And let's label this U1 and this as U0. So instead of having the price change, let's say that the government again wants to control prices and instead change the utility level or change the income of the consumer such that his utility level would still reach the new utility level given the price changes. So what happens here is the consumer, instead of having the price change to increase his utility level, would have his income or his budget change instead. So this yellow budget here would shift to the right until it becomes tangent to the new utility level. In short, the equivalent variation is the change in income that the consumer has to get or give to get to the new utility level instead of the price change. So what we're trying to find is actually how much we have to change the consumer's income, so that he or she would now stay on the new utility level after a supposed price change. So what happens is our target utility would be the new utility level. So again, we have our expenditure function P1, P2, and U, and this would be equal to our equivalent variation. So again, the equivalent variation is looking for the change in income that the consumer would have in lieu of the price change so that he would now be on the new utility level. On the other hand, when we talk about the CV or the compensating variation happens after the price change. So we have to compensate the consumer for the price change so that the consumer could stay on the same utility level. The equivalent variation wants the consumer to change his utility level. So the target utility level is the new utility level, whereas the compensating variation's target utility level is the old utility level.